Hello, welcome back to Introduction to Operating Systems and Virtualization. My name is Scott Neal. Today we are looking at availability and backups. We're going to be defining what availability is today, how fault tolerance plays a role in improving availability for your network, both in the physical and virtual worlds. We're going to be looking at some availability options that are available to you in physical machines, in virtual machines. We're even going to be talking about availability across multiple virtualization hosts today. And we're going to be discussing the role of backups, the types of backups, how we can implement different types of backups to preserve data and operating system integrity while minimizing our backup window. Last but not least, before we leave today, we will be discussing imaging as a backup solution. So what is availability? Well, availability really refers to the ability of your environment to maintain its integrity and accessibility to your users. And this has been a focus for administrators for a long time on how we can improve availability. It comes as no surprise that if systems are non-functioning and not available to your users, that they lose productivity. And a loss of productivity equates to a loss of revenue. That revenue loss can generate exceedingly high losses over a very short period of time, depending on the criticality of the infrastructure that's down. So network administrators have been focusing for quite some time on ways that we can improve the availability of our server infrastructure, particularly critical servers, and make sure that they're available to our users. One of those means is through the use of fault tolerance. Fault tolerance is the ability of a system to continue functioning while part of that system is failing. So fault tolerance, when we think about fault tolerance, it's not uncommon to think about server, particular server hardware. Even the most inexpensive of servers has more than one power supply, for instance, so that if one power supply fails, the other one will immediately kick in and there is no loss of accessibility to the server. But this is not the only fault tolerant solution out there, so we'll look at some fault tolerant solutions in a minute. Administrators talk about how much availability that your system has. This is particularly important when you're out soliciting vendors for cloud-based solutions or software as a service solutions through the cloud networks. One of the things that you hear from the sales pitches is the amount of uptime that the system has. And it's not uncommon today to hear people talk about 99.9% availability or 99.999% availability. These are very high numbers. When you think about 99.9% availability, you're really looking at less than 8.8 hours a year of downtime for that system. And when we talk about 99.999% availability, that really looks like less than 5 minutes a year for downtime for a system. So we're beginning to see these numbers improve. Each year we see more and more network environments move into this 99 plus percentile environment when it comes to availability. So how do they do that? Well, there are a lot of traditional solutions that we've been implementing for a long time. And earlier in this lecture series, we discussed RAID in some detail. We talked about RAID 0 or striping having no fault tolerance. It's all about performance. We talked about RAID 1 or mirroring and how that is completely all about fault tolerance, because now we have two sets of disks. One is writing data just like the other. So if one disk goes down, the other kicks in. And then we talked about some hybrid solutions, including RAID 5, one of the more popular server solutions that we use as administrators to maintain a balance between high availability and fault tolerance and the cost of doing business, so to speak. Because RAID 5 is about striping with parity. And it's really a nice compromise solution if we're not going to go full mirroring. You see a lot of organizations using RAID 5 on a lot of server platforms, even today. So another method that we probably haven't touched on before is multipathing, storage multipathing. I'm not going to go into all of the low-level mechanics of storage multipathing in this lecture. All you really need to know about storage multipathing for now is that it really is just a technique for creating more than one physical path between the server and its storage devices. Now, this does have to be supported by the VM builder if you're doing this in a VM environment. This works really well in virtualization, by the way. So if we have a failure of a link to a storage medium and we've got that link duplicated in some way, then if that link goes down, we don't lose the availability of the system. So we can fix that link while the system is still up and accessing that storage medium. Another benefit of storage multipathing is that it does provide a certain level of data load balancing. So if you are running a database server, for instance, that has a lot of traffic on it, you might want to think about implementing storage multipathing as a way to improve availability and provide some data load balancing. Another more traditional method that we see for improving our availability through fault tolerance is something called NIC teaming or link aggregation. This is where I'm going to tie multiple network cards together, and I can do that to accomplish one of two things. Either I can go for more bandwidth. So if I have a server that is got a lot of network contention, I may want to do NIC teaming and set that up so that I can improve the bandwidth to the server. The other option, of course, is to provide fault tolerance. And the amount of fault tolerance is going to be largely dependent upon how I configure those NIC cards in my NIC teaming. So if I take multiple NIC cards, I team them up, and then I hook each one to different switches on my network, then not only if one NIC card goes down, but even if a whole switch goes down or a whole segment of that network goes down, I have not lost availability to my server. So NIC teaming is yet another fault tolerance method that we like to employ in critical server infrastructures. This is usually something we can set up in the operating systems. NIC teaming has been around for several incarnations of Windows Server, particularly Server 2008, 2010, Server 2012, and Server 2016. Clustering solutions are also available to provide some fault tolerance and to provide high availability. Clustering solutions like Microsoft Cluster Services, Oracle RAC, these can all be implemented in VMs as well, and we have the ability to implement them from VMs to physical servers. Virtual machine tools also do provide a level of high availability. We think about high availability in virtual machine tools through the use of the heartbeat monitor. So the machine tools can install a heartbeat monitor, which we can then use to monitor the server. And then if the server fails, then the hypervisor will be responsible for automatically attempting a reboot of that failed server, and it will not require any kind of intervention on your part. The same thing can be applied to applications. Machine tools are out there that can monitor applications at the application level, and it can be used to restart any failed application without having to restart the entire operating system. So that means that if one application fails on a server providing multiple application framework to your users, we don't have to shut down the accessibility for all the other applications to try to do a restart of that one application. This is particularly useful in those types of environments. And once again, no administrator intervention is necessary to attempt the restart. There is also storage and networking input-output tolerance solutions out there. There are quality of service features that are going to ensure that all of our critical application workloads are going to receive the proper amount of bandwidth that are prioritized in such a way to prevent contention on our or application interruptions due to excess of network traffic eating up all the bandwidth. In addition to these, all the other best practices that you may be aware of or heard of, or that we've discussed in previous lectures about fault tolerance and high availability, still do apply. Things like proper security, antivirus protection, having a intrusion detection system to thwart against hacking attempts and that kind of thing. These all are traditional methods that can be applied not only to the physical environment but the virtual environments as well. So if we actually take a look at some clustering solutions, in this diagram we are noticing that there are two or more physical servers that we have linked together via a network and that they're sharing some storage resources. The benefit of this type of a configuration is that if one physical server fails, then all of the VMs that are on that server can automatically be rebooted thanks to the use of some virtualization tools somewhere else in the cluster. Now, there are some things you need to consider if you're going to be implementing this type of configuration. We need to make sure that we have enough memory headroom during the planning stages. So if we're going to be implementing this kind of solution, then the host systems need to have plenty of memory to ensure that it can host the VMs, including the excess startup memory that's going to be needed to start those VMs. If you remember in previous lectures, we talked about starting up VMs does spike the memory. So plan ahead. Make sure that you have more than adequate enough memory on both of these servers so that they are able to migrate over these VMs and implement a restart. Another method that we can use is strictly the fault tolerance method of mirroring. So if I decide to mirror a virtual machine, then they're going to run in lockstep with the primary machine. And the benefit of this is that if one of the VMs fails, I can simply migrate over to the new machine and make that the primary machine. Once again, this is an automatic procedure. It's done without user intervention, and then when that happens, a new secondary is going to be created in that cluster. The benefit of that is that we are going to have pretty much an uninterruptible series of machines that if one fails, it will start a new one, it will create a secondary, and it will continue to do this until all of the host resources are exhausted. We have to make sure, of course, this is also a resource intensive maneuver here, the configuration. So we need to make sure that we have enough resources on the servers that are going to be responsible for running these machines. Another solution that's available to maintain high availability is the live migration strategy. vMotion is one of the live migration tools that we are familiar with. This is the ability to move a running virtual machine from one virtualization host to another, and it's going to be done without interrupting the user application. So the great thing about this is that when we decide that we are going to migrate a virtual machine from one host to another, we can begin the process. We don't have to shut down the machine, and it will evacuate the guests from the host, and it will work behind the scenes on the physical host and replace the virtual machine on the new physical host, including starting up the new applications and ensuring that the users are not disrupted by this procedure. Once the migration is complete, then the original virtual machine is shut down and the new machine becomes the primary machine, all without losing availability to your users. Another solution is storage migration. So this is similar to a live migration, but in this case we're going to be actually moving the storage itself. The process is very similar. So we begin by creating a storage medium. Once we've created that storage medium, then we can begin the process of moving the data from the one storage to the other storage. This is also an automated process, and it will allow us to migrate that data over seamlessly so that the users are not affected. The same strategies that we have discussed can also be applied in a larger scale when it comes to protecting data centers. So part of availability is not just making sure that each individual server has the proper amount of solutions applied for its level of criticality in the systems. It's also about protecting the data center as a whole. When I was at my old job, one of the administrators from one of the data centers that we had was trying to solicit us to move our servers, our internal servers, to their data center. And one of the things that they bragged about was this 99+% uptime that their data center had. And in the middle of our negotiation process, someone went out and cut the main power line to the data center. This was catastrophic, as the backup generators shared the same main power line to the data center. And so when they cut that line, it didn't take 1 day to fix it or 2 days to fix it. It took 3 days to fix that main power line to the data center, meaning that there were literally thousands of users without access to their server infrastructure for that data center. Needless to say, we pretty much quit discussing the option to move our servers into that data center at that particular time. The lesson here learned is that even though you have made significant contributions towards improving the uptime for your data center, disasters do happen. And that you have to have some sort of a plan of action to ensure that even if the entire data center itself becomes offline, that you have a solution available to bring another solution back online in a timely manner. This usually begins with some sort of a risk assessment. A risk assessment is just like it sounds. It is a study of all the possible risks that are associated with your networking environment or your server environment or your data center environment, analyzing those risks and establishing 2 types of criteria for each of those risks. One is probability. Probability means how likely will that risk occur in our environment. Things like water damage, things like malware typically rank pretty high. The other category that we need to think about is the potential damage that would occur if that risk happens in our environment. So we look at those 2 numbers. We generate a level there. We incorporate that into our risk assessment. We look at all the possible risks, things as mundane as malware, water damage, fire damage, to the more remote, at least in our area, like earthquakes. We assess all of the possible things that could occur in our environment. We determine which ones are more likely, and we also determine which ones of those we plan to address with the budget that we have available. The other thing that we do after we have established a risk assessment is to create a disaster recovery plan. And the disaster recovery plan is a step-by-step guide of what to do if one of these risks occurs in our environment. So in our area, we're susceptible to hurricanes. So if someone says there's a hurricane forecast to hit our network environment, we flip to our disaster recovery plan to the tab marked hurricanes. It gives us a step-by-step guide as to who to contact, put on call, what protocols we need to put into place, what machines we need to cover, and what we need to do to ensure that if, say, our network or our building goes underwater, where are we going to move to set up and establish a new data center framework. So that's what a disaster recovery plan does. And if you are moving into security, risk assessments and disaster recovery plans will be a part of your future. There are also some tricks that we can use to provide fault tolerance and availability even at the data center level. Things like replication solutions. We can do site mirroring. I know one particular financial institution that runs 3 site mirrors, partly because of regulatory compliance, but they maintain a nearly perfect availability rating. They went from an environment where they had downtime of 6 to 8 hours to a downtime of less than 5 minutes a day. So they are, through the use of mirroring their sites, they have provided a high availability to their customers, and they have provided fault tolerance, and they provided a method of ensuring through off-site mirroring of their data centers, literally a one-to-one mirroring of thousands of servers, that they can sleep well at night knowing that if something happens to their mainline data center, that they are not going to be shut down for business. And as you can think of, a financial institution, when they go down, that's costing millions and sometimes billions of dollars a day. Virtualization is another method of providing excellent coverage and another way of providing a very quick restore solution for your infrastructure. Through the use of snapshots, through the use of mirroring virtual machines, one of the great things about virtualization is, since it's going to extract that hardware layer, we can move virtual machines to virtually any hardware platform quickly and easily. So if I have made backup copies of all my virtual machines and I've got them stored in an off-site location, I can pick up the phone, I can call Dell, I can have servers delivered in 24 hours to another location. I can then take my VMs and apply them to those servers, and I'm back in business. This is very difficult to do if you're backing up, doing particularly like images of physical servers, because those physical servers are going to have hardware issues that you're going to have to resolve as you move them to new hardware. Chances are you're not going to be able to get the exact same hardware that you got in a very timely manner in the event of a catastrophic failure. So virtualization is one way around that obstacle. Another method, of course, is cloud-based solutions. Cloud-based solutions do offer additional protection for data centers. They can minimize or eliminate downtime altogether. There are, of course, some service issues associated with cloud-based solutions that you need to be aware of. You need to look at your service level agreements in detail. You need to look at the privacy agreements and things of that nature. And you need to decide what information you're willing to put out on the cloud versus what information you may want to tightly hold in your own controlled internal environment. Other than that, cloud-based solutions are a wonderful tool, particularly nowadays, now that they're encrypted from endpoint to endpoint. They're a wonderful tool for backing up data center infrastructure. All right, so speaking of backups, let's talk about backups today. Why do we need backups? Well, backups is still the second most overlooked part of any standard system maintenance, even at the corporate level. It is not uncommon to see people neglect backups or not take the use of backups seriously, or as seriously as they should in their environment. Obviously, backups are good for disaster recovery. We talked about some scenarios today where having a backup is critical for reestablishing your network infrastructure in the event of a catastrophic failure. But there are also other times when backups are just as important. If I have a loss of data integrity, if I have a user that calls me up and says, my database is corrupt and looks like it's been corrupt for a week now, and we need a copy that's more than a week old installed. You can't really tell them, well, we don't have a backup because we have a mirrored system. You have to remember that a mirrored system is doing just that. It is copying data in lockstep. So that corrupted version on server 1 is going to be corrupted on server 2 in a mirrored environment. So that is not going to negate the need of a backup solution. The same thing's true for checkpoints on virtual environments. Checkpoints do require the base VM in order for them to install correctly. So if the base VM becomes corrupted in some way, then your checkpoints are virtually useless. So it's going to be important that no matter what type of operating system and server you're running, whether it's a virtualized server environment or a physical server environment, you're going to be required to run backups. I had one of my guys today was talking about not having enough space on the on our backup solution to store our host server with all the VMs on it. And I said, well, we don't need the host server. If we have the VMs, we can build a host server and we can apply the VMs onto the host. And he said, well, we're not backing up the VMs because we have checkpoints. And I reminded him today, checkpoints are not a backup solution. You need to be backing up those virtual machines just like they were regular physical servers to some sort of backup medium, so that if they do fail, we do have a way to bring those VMs back to life. All right, now that we've established that you need backups, what's going to constitute best practices for a backup? Well, first of all, what is a backup? It's going to be an exact, verified copy of the material you want to back up. And we're going to want multiple copies of it. One of the reasons why we want multiple copies of it is that generally we want to keep a copy on site for easy restores and for validation. And we want a copy that we can store off site as part of our disaster recovery plan. We're going to want that data to be easily retrievable on the on-site location so that we can provide timely restoration to our customers. And we're going to want to make sure that that data is secure. And that means encryption, not only on the storage medium itself, but also in transit. We want to make sure that as the data is moving through the network to the storage medium, that it cannot be compromised. Bear in mind, just to reiterate, fault-tolerant solutions like RAID, checkpoints, these are not backup solutions. They will not cover you for deleted files or old versions. So you need to make sure that you have backup solutions for all of your critical infrastructure. Another tool to be aware of, another term to be aware of, is the backup window. The backup window really is the time required to complete a given backup. And it's really quite simply determined by how much data I'm going to be backing up divided by the speed of the network infrastructure. And that's going to give me a pretty rough window of time it's going to take for me to complete that backup. Now, the best strategy for maintaining a short backup window is to ensure that backups occur during off-production hours because of two things. First of all, if I'm running my backups during non-production hours or at the slowest production cycle in my environment, then my bandwidth is virtually clear and the backups will complete sooner, thereby shortening the backup window. The other thing that occurs is that if I have a lot of users attempting to work on data while I am performing a backup of that server, I am going to have inconsistent issues with that backup. So some of the data may be bad data. It certainly will be outdated data by the time it hits the backup medium. So we don't want to run backups during peak operation cycles. When a backup window does reach a peak operation cycle, then we're going to be straining our resources. We're going to be slowing down the network as a whole, trying to complete that backup solution. This leads us to some interesting issues, particularly in environments where we are running a 24/7 environment. Usually in a 24/7 environment, though, we do see ebbs and flows in the productivity cycle. So we are going to want to try to see what that ebb is in the productivity cycle, and we are going to want to make sure that we have devised some sort of strategy that will allow us the ability to complete a fairly intact backup in a very short backup window. There are some backup strategies that we can use to help us shorten backup windows and to alleviate any kind of storage issues that we may have for our backup solutions. The simplest type of backup, of course, is the full backup. A full backup is just like it sounds. It includes all the files. The benefit of a full backup is that it gives me what I would call ultimate protection. And it also allows for simple restoration of a server or of an operating system or data. So if I run a full backup, I have that one backup and I can reinstall everything off that full backup. The caveat to a full backup, of course, is that it's going to require more time to do that backup. It's going to have the longest of backup windows for our backup solutions, and it's going to also eat up a lot of storage, particularly if I am keeping multiple full backup file versions on my systems. Another option, if I need to think about storage or reducing my storage costs associated with backups, is the incremental backup. Incremental backups are going to only back up the files that have changed since the last backup, whether that's a full backup or another incremental backup. It's a much faster backup. It is going to be the fastest of all the types of backups out there. It is going to require less data per backup cycle than any other type of backup out there. It does, however, require us, if we're trying to back up something that's several days back or several days forward, we're going to have to not only install it from the full backup, but we're also going to have to use multiple incremental backup copies to get to the version that we're looking for. We also have the happy middle ground. That's the differential backup. Differential backup is going to back up all the files that have changed since the last full backup. This does provide easier restoration. The downside to a differential backup is that each differential backup after the full backup is going to increase in size until we make another full backup. If you're working in a high productivity environment, if we have a small or non-existent backup window in our environment, we may want to consider making synthetic full backups based on the last full backup we did and adding all the differential and incremental backup solutions, combining them to make a new full backup tape. This is not my preferred method of doing full backups, but it will work in a crunch. If you are in a very high productivity cycle, it's time for you to come up or create a new full backup, then the synthetic full backup is a solution for you. So if we were to visualize this, probably one of the hardest concepts that a lot of particularly beginning administrators have as far as understanding the difference between incremental and differential backups. So what we're looking at here is an incremental backup solution. And this solution is running over the course of 1 week. And the bluish copy down at the base of this diagram is and represents a full backup. The yellow, red, green, white, and I guess that's purple, those colors there are all representing differential backups that have occurred on Tuesday through Sunday. And as you can see from the diagram, each one of these backups is an individual self-sustained backup. And that means that if I want to, say, install restore a file on Friday, I am going to have to go through not only install Monday's full backup, I'm going to also have to install Tuesday, Wednesdays, Thursdays, and potentially Fridays incremental backups as well to get to the version that they want. Differential backups work differently. Differential backups are much easier when it comes to restoration. We once again have our full backup, and then you can see that we have differentials that run Tuesday through Sunday. And you'll notice that each of these differentials that we have run have one thing in common, and that is those differentials are getting bigger each day. And the reason for that is that we don't turn off the archive bit after we have backed up with a differential. So that means that the data that we backed up on Tuesday is also going to be backed up on Wednesday, Thursday, Friday, Saturday, and Sunday here. And only until we run another full backup will we turn off those archive bits. Another solution is file system snapshots. This is available through virtual machine environments, and even later Unix versions do support snapshots. Snapshots, even though I don't consider them a true backup, we can use them to provide a level of versioning. We can do snapshots several times throughout the day. We don't need to shut down the system. We don't need large amounts of additional storage media, and they do provide very, very quick restoration times in the event of some sort of failure on the system. So don't discount snapshots, even though I've said before, they're not a backup solution in and to themselves. They can provide a way to restore a box in a very quick method in the event of some sort of corruption on the box. Direct backups. Direct backups are probably the most common types of backups out there. We think about single user homes. The typical home user does a direct backup, whether it's to a DVD or some sort of removable drive. In the corporate environment, a direct backup usually points to a tape drive with some sort of auto loader or library associated with it. Either way, it's going to be directly connected to every server, and that's going to allow us to directly back up and restore the data. Benefit of direct backups: well, they don't eat up any network bandwidth. For starters, tend to be a lot quicker. We're not carrying data over the network, but they don't scale very well. So we don't see a lot of newer backup strategies incorporating a lot of direct backup. We do see a lot of tape drives out there still. Those tape drives are usually connected to a backup server, and that backup server and tape drive provide a total backup solution to the network at large. I've seen tape drives as big as a room before, still in production environments today. I saw a brand new tape drive not too long ago that they were using. It had 6 robot arms in it and it stayed busy. So we do use tape as a backup solution. Tape is a very cheap medium. It tends to store fairly well in climate controlled areas, particularly if we're not writing over it over and over and over again. So it is still considered a viable backup solution. Another option, centralized network backup. Probably one of the more common backup solutions today. We have one server we dedicated as a backup solution, and then we use it through the use of a service account, that is a user account that can authenticate to each of our infrastructure boxes, and it can then use that account to send data over the network to the backup solution and store it on their medium on the backup solution. A lot of times this involves a storage area network. Sometimes we have a storage area network backup solution. This is just a storage network, and all the servers and the backup drive are going to connect to, and that data is going to serve as the storage medium for our backup solution. There are also some Windows, built-in Windows utilities that are available to us to help us perform backups. Backup and restore. We have the ability to also back up and restore the registry through the registry backup utility in regedit, and of course imaging a disk. So I'd like to talk about at least a couple of these today. As far as using backup and restore, we can do that in Windows environment simply by going into the control panel, clicking on System and Maintenance, finding the backup and restore solution, and then I can do one of the following. I can either create a new backup strategy using the Windows backup wizard, and I can do that. Simply click Setup Backup, follow the steps in the wizard, and if I'm prompted for an administrator password or confirmation, I will provide it because it does require administrative approval, and I'm set to go. If I have already created a backup before and have a routine backup solution set up, but I have two choices. I can either wait for that regular backup to occur, or I can do a manual backup creation simply by creating a new backup by selecting Backup Now. I will once again be prompted for some sort of a password for confirmation, and then it will begin to back up to the drive of my choice for my backup solution. That means, of course, that your backup solution drive will have to be kept plugged in during the backup window cycle. There are some different types of backup media out there that you should be aware of. Like I said before, tapes are still out there. They are robust. They are a little bit pricey, but they do last a long time, and we can store them offsite. Optical solutions, CD-ROMs, DVDs, inexpensive, relatively small, fairly convenient. Flash drives, they're robust, they're convenient, they're fast, and of course hard disks. Hard disks are probably not my first choice for an off-site solution because they are fragile, they are bulky, But hard disk drives today are about as cheap as you can get, particularly with the advent of SSDs. Solid state drives, if you can afford them, make an excellent backup solution even for off-site. We can store data on SSDs, lock them up, have Iron Mountain or someone come pick them up, ship them out, and then recall them for testing or for disaster recovery. We also tend to use our storage media in a rotation cycle. We may create a rotation cycle where media is kept off-site for a period of time, times usually measured in weeks or months, then brought back, overwritten, and then with the exception of an archive copy stored somewhere, we reuse that medium again until we have exceeded the life cycle of that medium. Last but not least, network or cloud backups becoming ever more popular. They are dependent on network throughput. They are one of the downsides to using cloud backup solutions is that you are generally charged on the gigabyte level or terabyte level, depending on how much data you are storing. That data is going to ever be increasing, so your costs associated with that backup solution will always be increasing as well. File history has been around since Windows 8. It's a great way to do versioning. It really mimics a lot of the enterprise level utilities. We could talk about shadow copy, for instance, in the server environments that allow us to do versioning. File history is kind of the Windows single user operating system client system version of shadow copy. It can be automated. By enabling file history, I can now have versioning on my client workstation. Likewise, I can also create system images in Windows 10, and I can do this. In Windows 8, we got rid of the backup and restore option in the control panel, so doing system images was a convoluted method. We have brought it back in Windows 10. So now we can go into the control panel under backup and restore, create a system image, and now we can create our own system image for Windows 10. So if you are used to having that, that vendor copy of a system image that you revert back to, and then you have to go and apply all of your applications and all that just like it was day one out of the box, now you have a solution. Now you can go in and you can build your box the way you want it, add your applications, do your first round of updates, then create a system image and use that system image now for your recovery instead of the old vendor image. So what do we need to back up? Well, server backup requirements are going to be largely dependent on what you're using the server for. Depending on the criticality of the server, depending on what applications in the server you're running, are going to determine and drive what specific files, folders you're going to need to back up on a routine basis and how often that's going to occur. System state backups are going to create backups for all the critical system related components. So if you do a system state backup, that file can be used to recover the critical system components in the event of a fatal crash of the system. To back up the system, including the system state, which is also going to include all the system protected files, we're going to use the backup and restore wizard in what's called advanced mode. Or if I'm using Server 2003, we still can fall back to the NT backup utility. That backup utility looks something like this. We'll go in and we'll run the command wbadmin. We're going to start a system state backup, and in this instance we're actually targeting a drive that's mapped to drive E. And then once we get in there, we can then just start the process. This is a command line utility, but it is available, and we can revert back to this if we need to. Another type of image out there, the system image. It's an exact copy, of course, of the drive, and by default a system image is going to include the drives that's going to be required for Windows to run. So Windows, your system settings, your programs, and your files should all be included on the system image. I can then use that image to restore the contents of the computer in the event of a hard drive crash or if the computer stops working. I can also do a disk image. Now, a disk image is really a term that we use for a single file or storage device containing the complete contents and structure that's going to represent a storage medium. Things like hard drives, tape drives, floppy disks, optical disks, even USB flash drives, we can do a disk image of those. That's going to copy the entire state, by the way, of a computer system, and it can be later used to restore the system to exactly the same state. And in such cases, system images can be used for a backup. Another term that you may hear when we talk about backup solutions is disk cloning. That's the process of copying the contents of one computer hard disk to another disk or to an image file. We oftentimes do disk cloning as part of building a reference image for a disk or for a server or for particularly a client system that we're going to be deploying to the network at large. So there are several different types of imaging strategies that we can use. Why do we do imaging? Well, imaging allows us to do a reboot and restore. So the disk of a computer is going to be wiped. It's then going to be restored from a clean master image. And then when we're done, hopefully we have a full system that's in full working order and it's been completely swept for viruses and ready to go. We oftentimes use images, as I just said, for the provisioning of new systems, when we can deploy those either as an image on a disk or on a hard drive, or if we're very modern age and we're using Windows deployment services or Clonezilla server in conjunction with a Pixie boot server, we can actually push those out over the network. Hard drive upgrades oftentimes require imaging the original hard drive and then installing the new hard drive and then deploying the image to the new hard drive. Full system backups oftentimes can be completed using a system image instead of some sort of backup utility. And system recovery. If I have an original equipment manufacturer, that image is still around, I can then use their media to restore a computer to the original factory software configuration. The original equipment manufacturer oftentimes provides this as an image file. And of course, transferring to another user. I may want to create an image, give that image to the other user, and let them install that on the hardware they're choosing. There are some notes about disk imaging. Most commercial imaging software tends to be very user-friendly today. Ghost, of course, was the very first imaging software that was really available at a commercial level. Ghost, very command line oriented, more difficult to use, but tools like Acronis, Clonezilla are comparatively a lot more simpler to use for the average user. They tend to be automatic, very user friendly, but they may not create a full bit identical image. So be sure that you read up a little bit about how the imaging software works to determine what type of imaging you're going to be doing. There are really two types of images out there. There is the bit identical or sector by sector image that we do that really takes a picture of the drive. And then of course there's also Windows, and particularly in Windows, if we do a WIM image, WIM image, that is a file-based image. The advantage of file-based images is that they're comparatively smaller. Instead of recording, say, the same picture file 5 times as it occurs on the disk and storing that as part of the image, we would record that picture file once and then place pointers for the other 4 locations. That's going to reduce the size of the image, but more importantly, one of the advantages of a file-based image is that it allows me, through the use of Windows utilities, to go into that image and I can inject drivers, I can inject updates, and I can update that image at will without necessarily having to go back to my reference image computer, updating the computer, and taking another image of it to deploy that image. So when file-based images are becoming more and more prevalent in part of our strategies particularly for deploying new operating systems. So let's summarize. Today's service expectations have made availability a crucial part of server implementations. As I said, we really like to see that 99 plus percentile for our network environments these days. It's not uncommon to see organizations brag about 99.9 or 99.999% for uptime. But in order to do that, we have to use a combination of traditional availability solutions through the use of some physical solutions in physical environments, as well as strategies that we can deploy in our physical and virtual environments at the same time. That's going to help us achieve these 99 plus percentile availability requirements. Availability capabilities can cover a single virtual machine. Those same strategies also work for physical as well as multiple virtualization hosts or even data center environments. So we really need to think about and strategize on multiple levels when it comes to how we're going to achieve high availability. We're going to be backing up our systems. Backing up our systems is crucial. We cannot take for granted things like using RAID and using mirroring, using virtualization mirroring and things of that nature, and call them backup solutions. They are not. We still have to have some sort of a traditional backup solution for our critical infrastructure, particularly in the event of some sort of catastrophic failure or data corruption that may require us to go back to some earlier version. Imaging, of course, is not only a type of backup option, but it's also used for a variety of administrative functions, including deployments. Imaging, of course, is not the only backup solution out there. We do have the ability through the use of third-party vendors, and even Windows, internal Windows utilities now provide a pretty robust backup solution that we can implement in most cases. That's all I have for you today. I look forward to seeing you in our next episode when we're looking at cloud-based solutions. Thanks a lot. Have a good day.